Okay, another problem where the important thing is to understand physically what's going on, and then the math is not so bad. We add a solution of HCl to a solution of hydroxide ions. So we're adding these two solutions together, we're generating a new solution, and the point of the question is to determine the concentration of these ions in the resulting solution. A note, we're given a balanced chemical equation. These ions, when they're mixed together, are going to react. So some of the ion is going to be consumed completely, some of it is going to have a little bit remaining. All right, so we want to know how many moles we have of each of these ions that's involved in the reaction. So we're going to determine the moles of these ions from molarity times volume. As long as we're expressing the volume in liters, that's going to give us moles. So we're going to calculate the moles of H plus and the moles of hydroxide. We know these are the ions of interest because those are the ones in the equation. So we determine how many moles we have of each ion, and then we can construct a BCA table. One of these ions is going to be a limiting reagent. And since this is a 1-to-1 ratio, we can quickly determine that the limiting reagent will be the one that has the least amount of moles in solution. And once we know the limiting reagent, we can immediately go to our answer and say we know what the limiting reagent is, and its concentration is therefore going to be 0. The concentration of the other ions a little bit more difficult. We need to do a subtraction. We know all of our limiting reagent will be consumed, and we know that same amount is going to be consumed of the other ion. So we do the subtraction, and therefore we know how many moles of that other ion remain. So to find the concentration of that ion, we divide that number of moles by the total volume in the final solution.